So here are some heuristics to create header files. So these are not rules as such, but this is a general heuristic that is followed when header files are written. And it is good practice to follow these guidelines rather. So including header file guards is a must to avoid multiple header file include conflict. So there is something called as a header guard. So by mistake, if you include a header 2 times, then there is going to be a conflict. So your code is not going to compile. So we include header guards in such a way that if a header file is the first time the header file gets included, it will not get included. Even if you include the header file by mistake for a second time or more than that, those files are not going to get included. It will only consider the first one. So that is the job of a header file guard. So header file include guard is an absolute must. Okay? So this saves you a lot of headache. Otherwise, you'll have to be very careful about not including a header file twice and so on and so forth. Macros are allowed. So yes, we saw that. So hash defines and memory maps and everything are allowed. Type def is allowed. That is, you want to type def a variable or type def a struct. So we saw the type def struct. All of that we saw in memory access in the memory access code, especially the method in method 2 should actually be a part of the header file. So we saw it in the main just to learn, but it has to be in the header file. Function declarations allowed. So you can declare a function in the header file. Okay, you can say you can and you need to declare a function within a header file and include the header file. So you need not declare the function within the main. So those declarations are taken, and you don't need to declare extern for a function. If you include the header file, that is more than enough. Extern declarations are allowed. So in a header file, if you're using a particular variable global to one particular file, but it is not, say it's global to this file, but that variable is not global to this one, you can declare the global variable in the .h file, header file, and if the other file actually includes that header file, this variable automatically becomes global here. So we will be needing to use shared variables. Shared variables are needed in a lot of places, shared global variables, and external declarations generally are used for such shared variables. You don't need to do external declarations for function declaration. Okay, so functions if you declare a function externally, you can use that function anywhere. No definitions allowed for any data type and functions. That is, you please do not allocate any storage in the header file. So you don't do int a equal to 4, or do not allocate storage, or say you start filling up members of structure, or you assign a structure pointer. None of that is allowed. So allowed in the sense you can break the rule, but please don't do it. Okay, macros can contain code snippets. So in the macro, it need not be just something defined and some value, some variable and value. It can be defined, say square root x. So it can be hash define, say square x, which can be equal to x star x, something like that. Okay, so this is allowed. So now the above heuristics can be broken, but it will give rise to complications. So be careful about that. So let us have a look at our header file, and we'll see how it is structured for us to get a better idea. Let's erase this. Let's go into the IDE, and we'll see the header file that we use, that is used most here, and that is the core initialization header file. This is the include guard. That is, we do for this header file, we give it a name, core initialization stm32 f411xc.h. That is, we say if not defined, then you define it, and then at the end of the header file we say endif. That's it. So what happens is, it checks if this header file is defined when you include it for the second time. If it is defined, it skips this whole block. This whole block is skipped, so it is not included the second time. If it's not included, then it gets included. Otherwise, if you do, so this is already, so suppose it was included previously and you mistakenly include it again, it checks for this value and it says that it sees that it is already defined. It doesn't define it once again. So we can do type defs here. See, we have done a type def for different data widths. For example, int is uint 32t, short is uint 16t, char is uint 8t, and so on. These are the macros that we saw. I just kept it here for reference. That's the method 1 macros. And then then we have further defines, and then we have the function declarations. So PLL init and enable sysdig, and these functions that are declared can be accessed by the main. So, and you don't need to declare these functions as extern for that. You can just access the functions from main, as long as this header is included and this function declarations are seen by the main. You can call the functions. So we have some type def struct, as you can see. So this is a type define, and we have some extern declarations also. So we declare a variable as an extern. That's also, this is actually a struct variable. So we are declaring a struct as extern. Here again, extern. We have 2 functions declared, and then that's we close the if def. So we see we have not included any variable definition, or we have not included anything like that. No data is created here. We only stick to these few members in the header file, like so. No definitions allowed. So don't have any storage, and macros can contain code snippets. So we don't have any code snippets here. Let us have a look at the memory map file. That is the file that we spoke about previously. I spoke about the memory map file previously, and I said that I have made some changes to this file so that everything is included in this file. Okay? So it's easier for you to use. So when you get this code, you can just include this particular file, and you don't have to. There is no other include here. So these includes whatever includes you had here. That is commenting this section out. All the mapping information for the core and the system, everything is being brought into this file only for your convenience. And I made some more changes actually, but let us go through this file now. So these are certain addresses that we are defining now. Here it is just a number. It is we'll be using them as an address, as we saw previously. So these are just numbers. For example, SCS base, ITM base, DWT base, TPI base. These are all the base addresses of different memory areas. Okay, which system memory areas and peripheral memory areas. And then you say sysdig base is again it is the SCS base plus some address. Okay. NVIC base is again some SCS base and the offset from that, and so on and so forth. Okay. So this is how this base is calculated, and this is somewhat similar to method 1, as we saw. We are adding the base address and we are adding the offset from there. Okay. But then we are not dereferencing it in the way method 1 is dereferenced. That is the way we dereference a variable in method 1. Then comes all the data structures, each for the system control register and things like that. For example, this is for the system. It's a structure to access the system control and ID register. Okay? Not in the SCB. So this is not in the SCB, but so SCB is your system control block. So SCB is your system control block. Now, and we define SCB, and we will be able to recognize this because we have defined it in the way that we did previously. So we actually declared a variable in the define. Let's see how we did it. So It's just a memory refresher for you so that it is easier for you to understand. So memory access methods.c. So in this case, we had defined it this way. Okay, so we did a base address star sysdig base address star, and so on. Instead of this, this can also be written like so: hash define and then sysdig base. So it's a sysdig base, and then we put this value, and we don't have this. So if you comment this line out and now you run this code, this will act in the same way as this star sysdig base. This is just another way of writing it. Okay. So in case you are having a doubt as to whether it's going to work, let's change the make file to memory access methods and see if it works. So memory access methods.c. So that's the file we are going to work on. So let's put this on debug and see what happens. So this is what we saw previously. Sorry, we have to enclose this in brackets. Now let's try it. Okay. Now going down, and so value 1, as we saw previously, it was 0, and so sysdig base load. So let's see what sysdig base is. So let's go to memory, and the load was E00, E014, and so it is all FFFF like we saw previously. So this one is also working, and so on. So the code is going to work now as it does. So there are two ways of defining it. One is this way and one is through define. And the similar we saw similar approach in method 1 as well, and that is what we are seeing in the header file. So instead of this, we are declaring it as this. So every time sysdig base and load is considered, what is actually happening is we are this address is referred to, and the load element of that is actually accessed, and that is nothing but the second element of this particular structure. That is all. So these two are similar. So that is what we are seeing here. So let's close the debug. Similarly, we have the system control block, SCB, and then again we have a similar definition of SCB, and system control block has these registers. So there are 32-bit registers. All of them are 32-bit registers. So we don't have a problem of memory alignment, since all are 32, it is word aligned. So that is why there's no packed. You don't have a packed attribute here. Okay, this is the sysdig structure that we had worked with, and then we have the NVIC. So NVIC register is the register which controls the interrupt, and so this is the structure which maps to that memory. None of these structures will have addresses assigned to them, right? Like these are just structures which are mapped onto different memory areas. Like this one is mapped to the NVIC base, and NVIC base we saw previously was some value like this. This is SCS base plus 0x0100, unsigned long. UL is unsigned long. So that's how this map goes. And whenever we in our program, whenever we have to access these registers, we'll just do, say, for MPU arrow and whatever element we have to access within this register. So we might have to come back to this header file to actually see how these structure elements are named, but everything is done for you. So you don't have to create the memory map. This is the peripheral memory map. So this is the flash base, SRAM base, peripheral base, flash end, timer base, SPI2, and so on. So all the peripheral addresses are here. GPIO base is again APB1, AHB1 peripheral base plus 0000. So AHB1 peripheral base is actually the GPIO A base. And then again GPIO B base is this one plus an offset, and so on. Goes on like this. So if you go through the header file, you will also get an idea of where the peripherals and how the you can check out the data sheet, which will mention this directly, but then you can also gather that information from this header file. So here it's all defined, and then again the structures start. So if you want to access the ADC registers, this is how it is: the ADC1 base and then ADC1. So when you access it, it's ADC1 arrow something, say SQR2 or SRCR1. That's how you access these registers. So this is ADC. There's a common ADC common part. Then you have the CRC calculation unit, okay, debug unit, DMA controller registers, okay. So DMA, different different DMA entities, and then you have the DMA1 and DMA2, through using which you can access the different DMA bases. Okay, so it's a DMA type def, and this DMA1 is DMA1 base, and this is DMA2 base. So these are two different addresses, but it is using this structure only. So DMA1. So if you do DMA1 LISR, it will go to DMA1 base. If you do DMA2 LISR, it will go to DMA2 base and access the LISR. So this structure is used twice for two different pointers. Okay? So you can use this structure as many times, structure in the sense the type def as many times as you want. And then you have the EXTI, external interrupt, and then you have the flash. You have the GPIO type def and all the GPIO memory area is here. That is a port mode and output type, output speed, pull up, pull down, input data, output data. If you want to talk to the GPIO, this is the structure that you access it through. That's all. And then you have CFG, I2C, watchdog, and this is a RCC, okay, that is a reset and clock control unit. You have your real-time clock, okay, SD host interface, serial peripheral SPI interface, timers, everything is here. So your entire processor, everything that is required for you to access the different parts of the processor are all here. USB, these are all structures to access the USB of the processor, and then it ends. And as you can see, it is all, again, here you have a header card like we talked about. This is something that we have not spoken about, that is, if not defined C++, then if defined C++, then do a close bracket and things like that. So we are using C, so we don't bother about this, but this header file can be also used with C++. So if you do that, then you have to declare an extern C, and then you have to go ahead like that. So this will be needed. So this is in short how what your memory map file looks like. You can actually modify it and distribute it, and but you have to keep this license on top. So you have to mention this on top, and give a proper attribute, and then you can change the contents of this. So redistribution of source code must retain the above copyright notice, list of conditions, and the following disclaimer. Okay.